All right, let's get into it. You've got this awesome new power inverter, and you're ready to get some serious AC power on the go. Now, wiring it up, it seems pretty simple, but just one little mistake can lead to, well, let's just say some unexpected fireworks. So in this explainer, we are going to walk through the right way, the professional way to do this, so you get it perfect on the first try. So, you've got it out of the box. You see the red post, the black post, you look at your battery, it feels like it should be just plug and play. But honestly, that's the trap. This deceptive simplicity is exactly where really costly and sometimes dangerous mistakes happen.
You go to make that last connection and bam, you hear that sound. That's your fuse doing its job, but it's also telling you something is very, very wrong. And that's the best case scenario. You're just out a couple of bucks for a new fuse.
But what if it's worse than that? A big, nasty, sustained spark that can kill your brand new inverter, damage your battery, or even start an electrical fire. It's that terrifying moment that lets you know a critical rule was broken. So the question is, how do we make sure none of this ever happens?
Okay, before we even think about touching a wire, we gotta understand the science behind it, because this isn't magic, it's just physics. And once you understand why things go wrong, it's so much easier to make sure they always go right.
Here's the deal. Your inverter is incredibly thirsty for power. It tries to pull a huge amount of electrical current from that battery all at once. Now, if your wires are too thin, they act like a tiny straw for a giant drink. They create a bottleneck. That resistance generates a ton of heat, and that heat is what melts your plastic and pops those fuses.
If you only remember one thing from this whole explainer, make it this: the 12-inch rule. See, a fuse isn't just to protect your inverter, it's there to protect the wire. By putting that fuse right near the power source, you're protecting the entire length of that cable from turning into a fire hazard.
And here's a perfect visual of why it works. Imagine that cable gets pinched and shorts out somewhere in the middle. Because the fuse is right at the start, it blows instantly, cutting off all that power from the battery. Now, if that fuse were way down by the inverter, that entire cable would become a glowing red heating element before the fuse even knew there was a problem. All right, so we've got the theory down. Let's move into practice. Choosing the right size cables and fuses isn't just a friendly suggestion, it is the absolute foundation of a safe system. Using undersized stuff is, no joke, like putting bicycle tires on a monster truck. It's just not going to work. And listen, not all wire is created equal. You need to use stranded pure copper wire. You'll often see it labeled OFC, for oxygen-free copper. It's way more flexible and carries current so much better than the cheap aluminum stuff. For fuses, you're looking for something heavy-duty, like an ANL or a Class T fuse. They're built to handle the massive current draw we're talking about here.
Think of this chart as your best friend. Just find your inverter's wattage on the left, and it'll tell you the minimum size cable and fuse you need. So for a 2000-watt inverter, you need some seriously beefy 2/0 or 2/0 cable and a 250-amp fuse. And remember, it's a little counterintuitive with wire gauge. The lower the number, the thicker the wire. You can always go thicker than the chart says, but you can never go thinner. Okay, we've got our theory, we've got our correctly sized parts. It is time for the main event, actually connecting everything. Let's walk through the 4 absolutely critical steps in the right order.
But wait, before we even get to step 1, this rule is so important it gets its own slide. You always connect the negative cable first, and you disconnect it last. Why? Well, imagine you're tightening the positive terminal, and your wrench accidentally touches the metal car frame. If the negative is already hooked up, you just created a dead short that can weld your wrench right to the chassis. Not good. So, here's the game plan. Step 1, you've already sized your parts with our chart. Step 2, mount that fuse holder somewhere solid, within 12 inches of the battery. Step 3, connect your black negative cable first to the inverter, then to the battery. And for the grand finale, step 4, connect your red positive cable from the battery through your fuse and then to the inverter. We are so close. Everything is wired up, but whatever you do, do not flip that power switch just yet. These last few checks are what separate a clean, professional install from a total disaster just waiting to happen. Now, when you make that very last positive connection, you're probably going to see a tiny little spark, a quick snap. That is 100% normal. It's just the capacitors inside the inverter charging up. But if you see a big, angry zap, stop. Just stop everything. That's a dead short, and it almost always means you've got your positive and negative wires swapped. This right here is so important.
A connection that feels kind of tight is a massive fire hazard. All that current we've been talking about will hit the resistance of that loose connection and turn it into a tiny furnace. Incredibly hot, incredibly fast. It's a silent danger that's so easy to prevent.
So, how do you prevent it? Simple. It's called the tug test. After you've tightened down every single connection, I want you to grab each cable and give it a really firm pull. If it wiggles or moves at all, it's not tight enough. Crank it down until it is absolutely rock solid.
And that brings us here. This is your final checklist for a perfect, safe setup. You've got the correct fuse in the correct place. You're using thick, pure copper cables. Every single one of your connections is solid. And you've double-checked that red goes to positive and black goes to negative. You are good to go. See, by taking the time to follow these steps, you haven't just hooked up a gadget. You've built a safe, reliable, and seriously powerful foundation for any mobile project you can dream of. So the only question left is, what awesome thing are you going to power with it?
And just a quick final reminder, working with high current electrical systems like this does have real risks. If you ever feel unsure about any of this, please consult a qualified professional. This is for educational purposes only. Stay safe and build smart.